All right, today we're diving into something called MultiNets. And trust me, it gets right to the very heart of one of the biggest questions in all of AI. So, how does a machine actually understand language? I mean, really understand it. We're not just talking about recognizing words on a page, but grasping what they mean, right? It sounds simple, but that one single challenge, that's the engine driving so much of what we see in AI today. And you should really think of this as less of a dry, technical problem and more like a grand quest. The goal? To take all the messy, complex, nuanced stuff that makes up human meaning and somehow translate it into a logical form a machine can actually get its head around. Okay, so this brings us to AI's grand challenge. How do you get from just symbols to actual meaning? Look, it's one thing for a computer to process the letters A, P, P, L, E. That's easy. But it's a whole different ballgame for it to understand what an apple is. You know, the crunch, the taste, the fact that it grows on trees, its role in fairy tales, all of it. And this is exactly where MultiNets enters the picture. Now, this isn't some vague, hand-wavy theory. Nope, it's a concrete blueprint, a real plan of attack designed specifically to tackle this challenge head-on. The idea is to create a structured map of meaning that an AI can actually follow. Okay, so what is this thing technically speaking? Well, MultiNet stands for, get ready for it, Multi-layered Extended Semantic Networks. It's a mouthful, I know, but the core idea is pretty straightforward. To create a formal, structured way to represent what natural language means so an AI has something solid to work with. Right, so what does that actually mean in plain English? Let's just go back to that map idea. Think of MultiNets as a super detailed map, but for meaning. It's built specifically to help an AI wrap its head around complex ideas, not just individual words. And what's really amazing is that it's designed to be this universal map, something that can work across a whole bunch of different human languages. And you gotta understand, this isn't just some minor little tool. The people who created it literally call it the common core of all aspects of natural language processing. I mean, that is a huge claim, right? They're basically positioning MultiNets at the absolute center of any serious attempt to get machines to talk and think like we do. So the big question is, how does it actually work? Well, to really get MultiNets, you have to look at where it came from. It's got these two very different roots. It's where the super rigid world of pure logic smashes right into the messy, nuanced world of how humans actually think. It's a really fascinating mix. And this really breaks down those two sides of the coin perfectly. On one hand, you've got logic and structure. This stuff is built on systems like K-alone and description logics, which, are basically just ways of defining categories and how they relate to each other with mathematical precision. Think of it as the cold, hard, logical skeleton. But then on the other hand, you've got cognition and meaning. This side is inspired by thinkers like Wittgenstein, who basically said a word's meaning isn't in a dictionary. It's in how we use it. It's all about intent. So what MultiNets tries to do is slam these two worlds together. It takes the what from logic and combines it with the why from cognition. And that's how you get a much, much richer picture of what language is all about. Okay, so we have these two roots, logic and cognition. With that in mind, let's zoom out. Where does MultiNets fit in the grand scheme of things? Because as it turns out, it's a super important piece. But it's still just one piece of a much bigger puzzle when it comes to creating true machine understanding. Yeah, to get to that real deep understanding, you actually need all four of these pillars working together. So, step one, you've got MultiNets. That's your knowledge base, your map of meaning. But that map is useless without step two, context. The AI has to understand the situation. Then step three is belief, which is about reasoning about its own thoughts. And finally, step four, discourse. It has to be able to follow the back and forth of a real conversation. You see, they all have to fire in sync. So, why should you care about any of this if you're not an AI researcher? Well, the goal here is just incredibly ambitious. We're talking about an attempt to unify computer science with human sciences, like linguistics. It's meant to be a kind of universal model for knowledge itself. This is the kind of thing that could power advanced AI that can answer really complex questions. It could even act as a sort of universal translator, a semantic interlingua, letting totally different AI systems understand each other. At the end of the day, the crucial point is this. We're moving past just teaching machines to calculate things or follow simple commands. The whole point of systems like MultiNets is to teach them to genuinely comprehend. And that leaves us with a pretty wild final thought, maybe even a little unsettling. If we actually succeed in creating a perfect map of all human knowledge, then what's next? What's to stop us from one day trying to use that same approach to map consciousness itself? Now, that is a question for the future.